In SAP BusinessObjects Cloud, the model is the foundation for all of our exploration, a framework of measures and dimensions that provides a structure for the underlying data. For data exploration, there are two ways to get our data into SAP BusinessObjects Cloud. We can import it directly into a story and start working with it right away, or we can create a model separately and then connect to that and other models from inside a story. For this example, we'll create a separate model which will enable us to use a different interface to prepare and enrich our data. To get started, we'll create a new model, and for this example, we'll choose the Import a File from Your Computer option. First, we need to specify if the file is from the local system or a file server. In this case, we'll use a file from the local system. Next, we need to specify the file to import, and we can also choose the sheet. By default, the first sheet is selected. Finally, we can choose whether or not to use the first row as column headers. Now we're ready to import the data and begin the data integration process. Note that the data integration process in this video is specific to users with the BI Analyst license type and is the same for creating models from a range of data sources. A message states that because the dataset contains many rows, a sample of the data will be used for us to work with, and any transformations we make will be applied to the full dataset when we create a model. In the Details panel, we can see the number of columns imported and the number of rows sampled out of the total number of rows in the dataset. In the Model Requirements area, we can see that there is one data quality issue, which we'll look at later. In the Model Information area, the model name matches the data source name, but we can change it if we choose. We can also add a description, if desired, and change the currency from the default value of USD if necessary. To get a better overview of the dataset, we'll switch to Card View. Now we can see the columns from the dataset as a series of cards, with icons that indicate which columns have been automatically identified as dimensions and which have been identified as measures. For each dimension, we can see the number of unique values, and for each measure, we can see a mean value. Note that these numbers are based on the sample of the dataset, not the full dataset. Green bars indicate the absence of data quality issues, but red indicates the presence of problems that need to be addressed before the model can be created. We'll select the card to see what the issue is. In this case, there are two rows with invalid values, because the number is followed by a semicolon. When we select the value and switch back to the table view, the relevant cells are highlighted and appear at the top of the list. We have the option to choose from a range of suggested transformations and quick actions. Note that when we mouse over the transformation options, we can see a preview of the transformation before we apply it. In this case, we'll choose the Create a Transform option and then choose Replace. Next, we need to enter the desired value for the cells. The data quality issues have been resolved. We'll switch back to the card view. We can make additional modifications and transformations as necessary. First, we'll geo-enrich the store dimension, making it possible for us to view the store locations in geomaps. To do this, we'll select the store dimension and then add a dimension attribute. Dimension attributes enable us to designate certain columns as attributes of related dimensions rather than as standalone dimensions. We can define columns as descriptions, properties, as members of parent-child hierarchies, or as geolocations. In this case, we'll choose geolocation. We'll specify the name as store location. Note that in this case, we're using the latitude and longitude columns in the dataset to generate locations. These columns have been identified automatically. The icons for the latitude and longitude columns have now changed to indicate that they're used for geolocation. If we select one of the cards, we can see that the column type is identified as geolocation, and that the column is being used to define the location of the dimension store. Note that in this dataset, there are pairs of columns that work together, such as store, which contains store IDs, and store name, which contains store descriptions. We'll set the columns that contain names as descriptions of the associated dimensions. This means that the descriptions, rather than the IDs, will display when we add the associated dimensions to charts. We'll start by selecting the store dimension and setting store name as a description. Now we'll repeat the process for the other dimensions. If desired, we can reduce clutter by selecting a subset of cards and focusing on them by clicking the eye icon. We'll select just the dimensions and measures so we can hide the cards for the attributes. Note that we can return to the full list by clicking the icon again if desired. We also have the option to sort the cards in the original order, which reflects the order of the columns in the data source, alphabetical order, reverse alphabetical order, or by model structure, which displays the measures first. Before we validate our sample, we can view the History panel to see the series of transformations we've applied. These changes will all be applied to the whole dataset when we create our model. We have the option to delete any transformations if desired. For this example, we'll leave all transformations and validate the sample. The validation is complete and no errors were found. Now we're ready to create the model. We receive a warning that when the model is created, we'll be unable to return to this space to make further changes. Once the model's been created, it opens and we can make additional adjustments in the same environment we would use to create a blank model. Note that any measures we created are automatically generated as members of the account dimension. There are also a number of additional columns we can populate as necessary, such as to specify the appropriate unit for the measure values, choose an aggregation type other than the default type of sum, or set a display scale. Each dimension displays on a separate tab, and we can make changes as required, such as opening the dimension preferences and enabling data access control, which allows us to specify the users with read and write access to each member of the dimension. Thanks for watching.